morning, everyone. So this is joint work with Brenda Patanaik and Brian Murray, and it's part of my dissertation, which I completed 5 months ago. So, yeah, that's not better. Okay. So I'm going to show you the results of the impacts of protected areas on a bunch of proxies for ecosystem services. And I'm going to argue that we need to branch out from the traditional traditional deforestation outcome and start looking into more relevant for conservation metrics. And then the second thing that I'll go a little bit into today is beginning to look at the mechanisms of why protected areas actually work or don't work. So I'm going to show you how institutions actually impact the performance of protected areas. So my key points are really need to branch out from deforestation. And then second point is we need to start thinking about the mechanisms that are driving the effectiveness. All right, so this slide is not supposed to be inclusive. So there are a lot of studies that I've left out. But my point here is that most studies so far have focused on the average impact, and for only very few outcomes. Most people look at deforestation, which is easily proxied by geospatial data. But and then some people look at poverty using census data, and then there are some studies that actually have household data, and they are able to look at more relevant indicators. And then more recently, people have started looking at the heterogeneity of outcomes. So not only average impacts, but how do the impacts vary according to where you are in the landscape. Also the type of protected area you have. So strict protected areas may not necessarily be as effective or less effective than multi-use protected areas. And then some people have started looking at the new outcomes, for example, fragmentation or reforestation or the incidence of forest fires. Those studies use quasi-experimental methods, but still there are very few of those, and very few actually get at the mechanisms of why protected areas work or do not work. So this slide is supposed to illustrate why deforestation is not very informative. So we're looking at conservation interventions. So the goal of those is actually help protect the environment, right? But deforestation doesn't really, deforestation gives us the amount of habitat, but not actually how this habitat is distributed across the landscape. So what you see in this big block here is all forest. So all the colors, anything that's in color is a forest. But there are different types of forests. So there are edge forest pixels. Those seem to be very disturbed. So those are given in yellow. Those tend to have different vegetation, for example, different microclimatic conditions, just because they get more sunlight, more species are open to predation, there are more pathogens in those. So in other words, we may not want exactly to have more edge effects. On the other side of the spectrum are core areas, so those are given in green. So those are really good for species just because they are undisturbed, less light, less predation, less pathogens. So in other words, my point here is that not all forests should be considered the same, and we should look at how the forest is actually distributed across the landscape. We want to conserve large core areas and not small fragmented patches. Okay, so this slide is supposed to show just that there are links between human well-being and the natural environment, and those come through disease control, for example. So less mosquitoes are in areas that are not as disturbed. Mosquitoes carry diseases like malaria or dengue. So natural areas also provide a source of fuel. So poor people need fuel to cook and all that. They may be a source of revenue from tourists. And they also may provide income for the district, for example, through allowing logging. So this is a slide really quickly on the methodology to make sure that we're on the same page. So what matching methods do is they try to use a bunch of observable characteristics and identify units that are protected to observationally similar unprotected units. So the key thing here is that the choice of covariate is very important, and that should be driven by theory. So for example, we should be matching protected areas to similarly threatened unprotected areas. Ideally, same population levels. So just use the observable characteristics. In this slide is just the shape, the size, and the color of the dots. Right. Okay, so what we do for our Indonesia studies, in order to isolate the causal impact of protected areas, we use matching methods, and those for the most outcomes, we use difference and difference propensity score matching. What this means is that the outcome is the difference between, is the change in some outcome levels, for example, how deforestation changed between 2000 and 2006. And the ADT is the difference between the changes for the two groups. And then afterwards, we do post-matching adjustments for the bias and variances. And then additionally, we do robustness checks in terms of how sensitive are the results how sensitive would the results be if a linear unknown covariate existed. And then we play with different definitions of what the treatment is. So the data we use for these studies are village level from Indonesia between 2000 and 2006. We focus on conservation protected areas, and those are categories 1 through 4 using IUCN classification. We use a binary treatment variable. In other words, a village is considered protected if at least 30% of it is within a protected area, and 0 if it's not in a protected area or anywhere close to protected area. So the control observations all forested at the baseline. And then the outcomes we consider are net deforestation, the forest fragmentation, things like edge effects, core areas, air quality proxies, and then in the incidence of forest fires. And then the socioeconomic variables are things like fuel dependence and poverty. And also disease incidence. And the diseases we consider are malaria, acute respiratory infections, and diarrhea. And then the covariates we choose are for location. For example, we make sure that we have the same variables or the same observations in terms of distance to ports, cities, major towns. And then also physiogeographic variables, things like slope, elevation, baseline forest cover. And then socioeconomic controls we use are village development indicators. For example, does the village have electricity or not? Things like population density, crime levels, the type of property rights, whether it's customary ownership versus private ownership, and then the poverty rate. Okay, so these are some results. The way to read this table is that, so this is the treatment level. In most cases, we use the village level except for the cumulative, so this is particulate matter 2.5 micrometers. The only difference here is that we use the sub-district level because the resolution of this data are really huge, so village data was not appropriate. And what we find here, so this column is without the bias adjustments, this is the one with bias adjustments. And negative signs means that forest cover increased in the treated areas more than it did in the control areas. So in other words, we do find that protected areas actually reduce deforestation. The other interesting thing is that actually they increase the amount of core areas. So in other words, not only the total amount of deforestation, but they were good for preserving these core areas. And we also find that at the sub-district level, they were associated with less particulate matter. So in other words, cleaner air at the sub-district level. So did conservation in protected areas actually improve welfare? And what we see here is that using different proxies of poverty, we find that they had some impact on whether or not more people applied for these poverty certificates in 2006. So it's only a cross-sectional area, but what we do find that in treated areas, fewer people apply for those. And the other thing that we find here is that in protected areas, people were more dependent on fuel than they were in the match control. So in other words, decrease in poverty, but fuel dependence did not change that much. And then the environmental disease incidence, we find a reduction in diarrhea, and that was the only statistically significant variable. Okay, so we see these patterns, but the question is, why are we seeing them, right? So in a different paper, we start looking at the institutional framework and how that interferes or impacts the performance of protected areas. So what we do during this paper is we consider the outcomes of the effectiveness of protection as the result of the interaction of 3 sets of actors. So we have district governments, we have logging firms, and we have communities. So what's interesting about our study area is that in 2000, decentralization kicked in, which meant that district governments all of a sudden had to raise revenue for themselves in order to support their activities. And one way to raise revenue was to hand out concessions to logging firms or oil companies. And then the second thing that happened in 2000, in the year 2000, is that property rights was over forests was assigned to people. So in other words, communities got the user rights of forests. So our framework here suggests that whether or not logging takes place. So logging firms bribe government officials and they can log anywhere, or but whether or not logging actually takes place depends on whether communities fight off logging firms. And this is the same framework that NGO will use in their paper. So whether or not communities are strong enough to fight off logging firms depends on the benefits community get from protected areas, right? And also their electoral participation. Okay, so what we find here is, so we repeat the matching using as a treatment each protected area from 1 to 4. So in other words, and then we do, instead of linear regressions post-matching, we do non-parametric regressions. So what these results show is that depending on how much forest you had to begin with, protected areas have different effectiveness. So if you had very little forest and you really depended on that forest, you are likely to see very improved effectiveness. So protected areas worked in areas where you had little forest cover to begin with, but were not effective when the forest cover increased. So, the way to read this, if it's negative, it means that protected areas were effective. If it's positive, they were not effective. So what we see here is that, and these are the different protected areas. So we have strict reserves, national parks, and species management areas. One category is missing, but that's because we had only one protected area at that time, and that's category 3. Okay, so, and we see the same trends in poverty. So this is deforestation. So protected areas reduce deforestation when we have little forest. And then they also reduced poverty when we have little forest. So in other words, protected areas seem to work when people, they reduce, So in other words, protected areas work where you have a little of them and people are really dependent on them. And then this is for property rights. So same idea, if it's negative, deforestation will get reduced. If here it's negative, again, poverty got reduced. And again, we have strict protected areas, national parks, and then species management areas. And the horizontal axis is the fraction of land under private property. And then this is for deforestation, this is for poverty. Again, what we find is that when you have more private property within a village, you tend to find that protected areas are more effective. Right? And that's because the benefits are captured by, there are no collective action problems. So the take-home messages I wanted to carry to hammer home are that, first of all, we really need to branch out from the traditional deforestation metric and try to be more creative about how the forest is actually allocated, also consider how conservation actually impacts human welfare and what are the incentives for people to conserve the forest. And then second point is that protected areas seem to be effective where there are tangible gains to local communities, and those can be captured by the local communities. And the second, the thing that I didn't go through, but we really need to consider, is the institutional framework. So protected areas should not be looked at in isolation.